In this video clip, we're trying to using this example to show you the correspondence between time domain and the frequency domain. So we have a triangle signal, x of t, and we're asking you to get the signal's spectrum. It is pretty straightforward because we know that triangle signal can be treated as the convolution of rectangle signal by itself. So this is the spectrum for the triangle signal. What if we're asking you to sample that signal with a interval t equal to 0.1 second? What is the spectrum? That is pretty straightforward. Discretization in the time domain corresponds to periodization in the frequency domain. So the sample signal spectrum will be a periodization for this spectrum. We can also use the second version to represent the spectrum using capital omega as the independent variable. And if we plug in the parameters, this is the specific form of the spectrum in the frequency domain. And if we show only one period of the spectrum, this is the graphic representation for that signal. What if we are trying to periodize the original signal in the time domain? So here we used a period t sub none equal to 3 seconds. And here is the periodized signal in the time domain. And what is the spectrum for that signal? Because this is the periodic signal, so we have to use Fourier series to calculate its spectrum. By definition, we can plug the signal into that equation. Without going through the details, we can get the Fourier series for the new or for the periodic signal is equal to this equation. Now we can plug the spectrum in based on the omega sub none equal to 2 pi over the period t sub none. And here is the specific form for the spectrum. And again, we can plug it in the frequency domain. Periodization in time domain corresponds to discretization in the frequency domain. The last question, if we sample the periodic signal at an interval equal to 0.1 second, we get a periodic sequence. What is the spectrum for that new signal? We have this already in the last question, and here is the Fourier series relationship between the omega sub none and the period. We try to do the sampling. So we plug the expression into that equation. And here is the simplified expression. Now, based on the definition of inverse discrete Fourier series, we can get the spectrum or the Fourier series for the new signal. And here is the plot of the spectrum in the frequency domain. Again, we show only one period. So to summarize the example here, we have the original signal in time domain and its spectrum. If we're doing sampling in the time domain, then discretization corresponds to periodization in the frequency domain. So this is only one period of the spectrum. What if we are doing the periodization in the time domain like this? Then in the frequency domain, we have to do discretization for the original spectrum. Then this is the new spectrum. And what if we are sampling the periodized signal in the time domain? Then we have to do periodization in the frequency domain. And here is the corresponding spectrum for this signal. Thank you.